Hello and welcome to Code Skwela. In this video, we will be implementing a stack. So first off, what is a stack? So a stack is a data structure that follows LIFO flow. So what do you mean by LIFO or LIFO? So the word would be like this, LIFO. Okay. So LIFO means last in, first out. Okay. So if you can recall, or if you have been to our previous tutorial, which was the queue, or the one titled Let's Implement a Queue. So that was that the queues follows the FIFO or FIFO flow of uh, data. Okay, so that means first in, first out. So this one, or a stack, would be the opposite of it. So last in, first out. All right. So you can think of a stack as a stack of plates, wherein to use a plate, one would take one on top. So what is on top gets used first, and the one on the bottom gets used last. Okay. So let's do a quick Google and see what a stack, or let's just search for stack of plates. Okay, so if you can see, we have several images here, right? So a stack of plate would look like this. If you have been uh, looking at your kitchen, then this would be what a stack of plates would look like. Okay, so the one on the top would usually get used first, or commonly gets used first. Every time someone would want to eat, then someone would just take a plate on top. Okay, and then the last one, or the one at the bottom, would be the last one that would get used, right, or utilized. So a plate would have several behaviors, or I mean, sorry, a stack. So a stack would have several behaviors. First off would be you have push, and then pop. Next would be peek, and then count. Okay. So push would be adding an item on top of our stack. Okay. So that would be push. So like pushing a value or an item in your stack. So pop would be removing an item on top of your stack. Okay, if you have a stack of plates, if you remove the one on the top, that operation or behavior is called pop. Okay, and then peek is looking at the value of the top item. Okay, without removing it. Okay, so it's much like pop, but with pop it does not get removed. Okay, and then we have also count. Count would be uh, returning the number of items in your stack. Okay, so let's start working on our stack data structure. So first off, we will be creating a class which we will name stack. So simply as stack. And then next, with our stack, the data store, or the backing, uh, sort of like the storage for our data for the stack, we will be using an array. Okay, simply an array of ints or integers. Okay, so we will declare a private field. Let's just name this as data, and then initialize it into an empty array. Okay, oops, we forgot something. Data type. All right, so now we have that. So that this time, this would be now uh, this would hold our data for our stack, right? Next is we will be implementing the push method. Okay, so let's start with push, and then we will receive or accept a integer, a value of an integer type. Okay, that would be our parameter. And then first off, we will be taking or storing some temporary data to hold our uh, data temporarily, because with this one we need to have our array increase in size every time we add an item. Okay, in this case we will expand our array by one. Okay, and then let's just do a data dot copy. So the copy to method for our array is sort of like a convenience method. So it allows us to easily copy our data from one array to another, okay? Starting on a specific index. And then next is we will assign the value of our topmost or topmost item, okay, on the end of our array, which means it would be uh, on the top, okay. Data, and then we will replace our existing array with the new array that has the new data or new value added to it, okay. I hope you are able to understand the logic of this method, okay. So next is we will try to test out our push method, okay. So let's first create our stack, and then we will add some values to it by pushing, okay. Stack that push again, then let's do push 3 times, okay. And then let's try running this one, okay, and hope. Oh, nice. So my computer seems to be working quite fast today, okay. Now, yeah, I guess this somehow indicates that our program is running fine, okay. But somehow we have no way of looking at the data inside of our stack, okay. So let's just add a convenience method so that we can see the data inside our stack, okay. Let's add a print method to our stack so that it would be much easier for us to see the data of our stack, right? So let's just loop through uh, each of the items in our array, okay. So let's just console that write line, oops, data. Simple as that, okay. Let's try and test out our new print method, print, oops, okay. Then let's run this one, okay. So now if you can notice the output on our console, we now have, or we have printed out 3 values, right? So this would be push number 1, push 2, and push number 3, and then the end of the print, this would be the final output, okay. Okay, seems like our push method is working fine. Okay, cool. Now next is we will be implementing the pop method, okay. So if you can remember, pop is removing an item on from the top of our stack, okay. So with pop, it would return the value that has been removed, okay. So in this case, we will be returning a data of type integer, and then you have no parameter since basically the pop would be just removing the top, okay. And so first off, we will have to check if our array is empty, because if it's empty, then there's no point in returning something. But to simplify our pop method, we will just return a -1, indicating that, yeah, our stack is empty, okay. So we will be the stack, or our stack would be just dealing with positive integer values, okay. If data.length is 0, then let's just return -1, okay. Simple as that. Next up is this would be a bit I don't know if complicated, but let's just uh, do this. So for the pop, our array or data array would have to shrink, okay, in size. So in this case, data.length would be smaller than our current data. So we will be storing temporarily. We're creating a variable to store our data temporarily, and then we can't use the copy to convenience method since uh, this since we can't just copy an array from another array if the destination array would be shorter than the source array. So let's just loop through our data, and let's do this in this way. Let's do it in this way. So we will copy each of the values from our current array into our temporary one. Okay, let's just shrink that. Let's make this a bit more compact since it's only one line. And then let's get a hold of the top data, and then we will have to replace the current data with the new one, the shorter one. Okay, and then just return the result. Okay, so now we will have to test this one out if this would work. So let's do several, just add another line here. Let's put a separator to our, oops, okay, like that. And then let's print first, and then here we will do a pop. Okay, dot pop, and then we will do, and we will print out again the result. Okay, if indeed our data has been removed. Okay, so let's try this one and run this. Okay, something is wrong, out of bounds. Okay. Let's check that first. Okay, okay, there's something wrong here. We're missing something. Of course, we're only dealing with index 0 and then up to the end, except the last one. Okay, somehow we missed that one. Let's try running this one again. All right, now we have our result. So let's check. So you can see we have pushed three values, and then at line 13 we have, or we perform a pop, and then we print it out again at line 15, and we can see that we have only two values on our stack since we have popped the last one, or did a pop, okay, or remove the topmost data. Okay, so that seems to be working fine. And next would be implementing the peak. Okay, so peak would be very simple. Okay, let's peak would be very simple. So again, we have to check if our data or our array would be empty, and we'll just have to return a -1. Or else if it isn't, then let's just return the last of our data, or the end of our array. Okay, so that's it. And so again, we will do several tests for this one. Let's do a, so right, and then print, and then let's do a peak here. Peak, it's just that one. Let's try this one out. Okay, nice. Okay, somehow, no, we're doing something wrong here. So let's do a, since it's a method that returns a value, then we will have to do this. Can't just make a simple call. Okay, let's try and run this again. And yeah, now we have our 3. Okay, so it seems to be working fine. At line 15 we did a peak, then the result of it is sent to right line, which is printing the result. Okay, which is 3. Nice. Again, we will do another one. We will do a pop. Let's print first, and then let's do a stack that pop. Okay, and then see the result. Okay, okay, now we did a pop at line 13, and then when we do the peak, it returned 2, value of 2. Since we did a pop, 3 would be removed, the next would be 2, okay? So that seems to be working fine also. So I guess the last method that we will be implementing will be count, okay? So again, count is quite simple. Let's just return the number of items of our stack, okay? So basically returning the length of our internal array, okay? Let's do some tests. Let's modify this a bit, okay? Count. Let's do string interpolation. Stack count. Okay, let's do that. Okay, now we have 3. Oops. String count result into 3. Let's try more. Let's try again adding stack push 4, stack push 5. Then let's see, test out if it indeed it would return 5. Okay, cool. Now you can see that the first call to stack that count is resulted in 3, and then we added another 2 value, we pushed another 2 value, and then when we did the count, then it has updated, and then it would return 5. Okay, yeah, seems to be working fine for our stack. All right, okay, so it looks like our stack class is complete. If you think we can improve our code or how you would approach the implementation of this, then please let us know in the comment section. Okay, we have reached the end of our tutorial, and I hope you enjoyed while learning. Have a wonderful day, and may the code be with you.